The second part of this lecture series covers diet and locomotion under the realm of primate ecology. So we're going to focus on what primates eat and how they move about in their environment. One of the foremost questions, of course, is what do primates eat and why? And of course, why and how are some of the most difficult and challenging questions to ask in science. But we've been able to come up with a few ideas as to why and how certain primates subsist on certain foods. Here are some general categories that are used to focus on the specific foods that are consumed and eaten by primates. So understand that these aren't mutually exclusive, where somebody or some primate says, "Oh, I'm only a fruit eater. I won't eat anything else." That's not true. We know that some primates will move in and out of certain feeding habits, and that can be dependent on a number of different factors. Resource distribution, certain foods might not be available. Fruit is often seasonal and difficult to get, and you need to know where it is. But you will see some general categories of primates, like ones that live in the Amazon, may primarily subsist on leaves. And so we have been able to lump primates into three main categories, including fruit, leaves, and insects: frugivory, folivory, or insectivory. Frugivore, folivore, or insectivore are all kind of synonymous terms here. A primate that subsists mostly on fruit, a frugivore, this includes things like fruit and seeds. A folivore is a type of primate that would subsist on leaves, and some primates like young leaves, some like mature leaves. I'm sure some of you enjoy baby spinach or baby carrots, right? And they may also eat things like flower blossoms and extract nectar from them. Insectivores, when we look at them, sometimes smaller primates will subsist only on insects, and this includes some of the crunchy adult insects that have a fairly hard exoskeleton, but it also does include things like larvae and pupae, as well as caterpillars. Now, again, you may find a primate that will subsist mostly on leaves, and they'll find an area where they can access pupae of an insect. They will eat those. But some of the adult insects, they are a little more challenging because they can move faster, they're very quick, and you have to know where they are. We have a pretty good idea that a primate's body size is a big influence on diet. Insectivores are oftentimes very small. That's because they're quick and they're fast, and they usually have really good hearing. There's a large emphasis on that, and they can find them. And they also have really sharp teeth in order to catch them. Frugivores are oftentimes medium body size. And then when we look at folivores, they actually look like they have the largest body size. The largest old world monkey is a baboon, and one of the Ethiopian baboons, they subsist only on grass. When you look at gorillas primarily eat leaves. Male gorilla can get up to 500 pounds even in captivity. And so body size has a big influence on diet, and sometimes there are a few rules that we've been able to kind of examine that will determine a primate's diet based on this. Here's a really good example of some of the trends that we see in body size and diet. And this was something that was developed by a primatologist named Rich Kay. There's a nice picture there of Rich Kay, and he came up with what's known as typically Kay's threshold. And this determined that after Rich Kay surveyed the diets of just about every living primate that he could get a hold of, he determined that a primate's diet uh, is primarily insectivorous, or they are an insectivore, if their body size is 500 grams or less. So that's half a kilogram. 1 kilogram is equal to 2.2 pounds. So this is a primate that is 1.1 pounds or less. And we have a number of them that are incredibly small. A pygmy tarsier can wrap pretty much its whole body around one of your fingers. And so they're small, they have very sharp teeth, and they're quick enough to catch insects. And so they'll get predominantly all of their foodstuffs from insects. But you'll notice also that they're, again, each one of these diets aren't mutually exclusive. You have some primates that will supplement both fruit and insects, and other primates that will supplement fruit and leaves. And then you'll also notice that, the folivores, those that primarily subsist on leaves, those are the monkeys that live in parts of the New World as well as the Old World. And you can see the largest living primate that's not human is a gorilla. And you can see that's on the far end of the scale in green. Here's a chart that you have seen even in your first laboratory exercise. It is a hypothesis that is generally well supported in biological or physical anthropology, and that is those primates that have long shearing crests on their teeth will typically be subsisting on leaves or insects. That's because to catch an insect and to break up the chitin, which is the protein that is made of their exoskeleton, you got to have sharp teeth or a sharp implement to do this. And the teeth are the tools to perform that activity, as well as leaves. Leaves are soft, but they're tough. And you also need something that is sharp that will also kind of break down that food stuff as well. When you look at the fruit of a frugivore or a predominantly fruit eater, they will have round and bulbous cusps, right? Now you're looking at the business end of the tooth here. On each one of these images, you've taken the upper jaw or the cranium, and you turned it upside down to look at the business end of the teeth that make contact with other teeth and your food. And so you can see that the fruit eater, the cusps are round and bulbous, and they have these steep basins because what you're really concerned with fruit eating is really mashing the pulp and extracting the juices. Now, look at each one of these types of teeth and think to yourself, which tooth row does my teeth look like? If you answered fruit eater, you're probably correct. I mean, you don't see many people that have very sharp teeth or long crests on their molar teeth like those primates that subsist on leaves and insects. Our teeth look like they're more adapted to fruit eating. The next question we have is, why do primates move around in different ways? And this is typically known as locomotor ecology or locomotor strategy or just locomotion. Primates typically have a number of different specific strategies to move about in their environment. If you look at human primates, we're bipedal. We walk on two legs, and we have to walk this way. We don't really have another strategy in comparison, unless you watch like American Ninja Warrior. You can see people are very, powerful, strong upper body strength. They might be able to move about like some of the primates we see in trees. But for the most part, we walk on two legs, and that's predominantly our only strategy that we use. You'll see that other primates can do this, but they can't do it habitually, or they're not obligatory like you. But let's explore some of these locomotor strategies that primates use to move about in their environments. Primates usually that are not human will have 4 points of contact on the ground most often. So they are quadrupeds, right? Ped meaning foot, quad meaning four. That's why when you say biped, were 2 points of contact with the ground. Now you have some primates that are almost exclusively terrestrial quadrupeds, meaning they're on the ground. This is something like a baboon, ones that live in the Ethiopian highlands, or the Hamadryas baboons that will live on the plains of Africa. You also have some primates that are boreal quadrupeds. Arboreal meaning being in the trees. And there are some primates that actually have what's known as a prehensile tail, equipped for prehension, meaning that tail can actually grab onto things. If you don't have a prehensile tail, it's just a tail that can be used for balance. Now they can wrap it around things, but it can't be used to support their body weight. Some primates can actually use their tail almost as a seat, because it even has dermal ridges and grooves that are the same that you have on your fingertips and the palms of your hand. When we look at other primates, mostly ones that are more primitive meaning that they are more closely related to other ancestral mammals, many of them will leap, right? But you'll see other monkeys take great leaps, and some will actually have, extra skin in their armpits and inside the inside of their legs, so that they can kind of glide a little bit. You also have slow climbing that is performed by some of the lorises, right? They're quadrupeds, and they're mostly in the trees, so they're arboreal, but they don't really vertically cling and leap. And that's the strategy we see among many lemurs, as well as other lorises, and even the tarsier, which is depicted here. Vertical clinging leaping, as you can see, is where the organism actually wraps its arms around a tree branch or tree trunk. And what they will do, and as you can see, that the knee joint is almost right next to the chin. This means you have really powerful legs. And so the primate will use its powerful legs to push off the branch, and then they will kind of shift their body so that they can move and shift around, so that their arms are in the opposite direction of the tree that they jumped off, and then they will find another branch. So this is known as vertical clinging leaping, or you may hear it or see it termed as VCL. When we talk about some of the apes, they have a locomotor strategy that is slightly different. And so when you look at the apes, all apes are terrestrial and arboreal quadrupeds. They can be on the ground or they can be in the trees. And their strategies are different in each one of those. You look in the right-hand quarter and notice a chimpanzee practicing bipedalism. Now, chimps, and matter of fact, all primates, for the most part, can actually walk on two legs. They can stand up and walk a little bit on two legs, but they can't do it for a long, period of time, and it costs a lot of energy for them to do that. They can't do it like we can, where we can do it continually and at a very low energy cost. So when we look at the apes in the trees, they perform suspensory locomotion. Like you, the other apes have what's known as full adduction of the forelimb, where you can actually take the ball and socket joint that's on your arms and move it in every plane of the body simultaneously. That allows you to take your arm and to swing it around, and your fingertips can make this cone shape. So we inherited this from the apes. Your arm is an ape-like arm, and it allows them to kind of swing through the trees. Now they also use their feet if they need to. And then there's a very specific form of suspensory locomotion known as brachiation. This is where you actually see almost exclusively just the arms swinging through the trees. This is a type of strategy that you mostly see with gibbons and siamangs, the lesser apes. You can see that in the brachiation picture here, look how long the arms are in comparison proportionally to the legs. So you can notice that the arm is much more emphasized than the legs in comparison to the orangutan here that has the red hair. On the ground, with the exception of exception of the lesser apes, there's knuckle walking. And so you'll see this in gorillas, chimpanzees, bonobos, and even orangutans, though sometimes they use their fists. So what they will do is when they're on the ground, and this doesn't hurt them, they actually have bony protrusions in the middle part of their knuckles that allows them to support a little body weight and propel them forward using the forelimb while they push off with the hind limb. The lab that you're going to work on for this week is actually a feature-length film about the bonobo. And when you watch that film, I want you to be very conscious of some of the components of primate ecology and sociobiology. What is the locomotor strategy of the bonobo? What do they eat? As well as where do they live? And we're going to work on the next part of this lecture series, the last part, which will focus on group living. So in your lab for this week, as you watch the feature-length film, you should be thinking, right? These 4 components that you're going to need to know for this whole section for each one of these groups: habitat, diet, locomotion, and the last part of this lecture series, focusing on group living.